Welcome back to our final presentation for the day. My name is Henrik Holmer. I'm an analyst here at Erik Bank. And the last company to present is Minesto, which is a company that has an exciting technology to generate electricity from tidal waves and currents in the ocean. And let me just remind you that we are live, so you can send in your questions during the presentation. And to present the company is CEO Martin Edlund. So welcome, Martin.
Thank you very much. It's a pleasure to be here, at least virtually. Apologize for that. I will give you both an introduction and an update to the company Minesto. We are one of the few listed companies in the world that develop a technology targeting the enormous renewable energy resources of the oceans. And what we target is tidal and ocean currents. So it's a linear movement, the big flows of the oceans that we're looking into, which is quite different in its nature and in its opportunity compared to wave, for instance. So if we take this picture here, it's a drone footage that means a lot to Minesto as a company. It is from the first towing of a 100 kilowatt system out to its grid-connected production site in the Faroe Islands a little bit more than a year ago. So we have, for the last year, taken the company into a situation where we are now in project development mode and moving into commercial scale up and rollout. And I think that's what we're going to focus a bit on here. But before we do that, let's take the next slide and look into a little bit of an overview of historically and what Minesto is as a company. We've been around for almost 13, 14 years now, so as a spin out from Saab, also a few years in the incubator at Chalmers University, and has been listed on Nasdaq First North since 2015. We're now around 60 employees, primarily engineering oriented and offshore operation oriented staffing wise. Now also with a more significant market and business development organization than we've had historically. We have in the technology and in the development of the company, we've invested around 100 million euros. It is a large portion of public investments into that, around 35-40%. So whether you like it or not, you are in a sense already stakeholders or shareholders in Minesto via your tax bills. And as I said, then electricity to grid is an extremely important milestone for new renewable energy technologies. It's like a before and after event for us. So that means a lot, having had over the year long periods of stable electricity production fed into the Faroe Islands and actually lighting some Christmas lights and trees also in the Faroes last winter. The market cap is around 250 million euros, and we have today, which we are really pleased with, we have almost 30,000 shareholders with Minesto, where most of them are small private shareholders, but we also have two long-term strong owners that sit on around 35% of the total ownership of Minesto, which is BGA and Core Spring, former Midrock New Technologies. And well, what is it makes this investment opportunity interesting? I mean, first and foremost, it is an enormous, let's say, difference between this technology and its performance and all other known technologies that target the ocean currents and the tidal currents in terms of cost competitiveness and performance in converting the energy. I'll spend some time and introduce the principles, the heavily patented principles we're using on that one. But I mean, that's the left corner of what you see here. And directly linked to this technology is a unique ability to reach into lower flow resource, which actually is the big potential in the world, which means then that we really move tidal and ocean current solutions from niche-based energy generating solutions to actually a mainstream opportunity to really contribute to the grid mix in many parts of the world. We can even claim that the total potential that we address will be equivalent to today's nuclear capacity on Earth, which you can imagine almost monopolizing such a resource puts us in the driver's seat in moving this into commercial use. And the natural resource itself is what makes this at large really relevant, because what we're doing now is that we're investing in solar and wind, which will take us only so far in terms of a net zero transition. So the predictability of tides and ocean currents is so important as a complementary resource. And it's also scalable, so we can use small-scale devices for microgrids, and we can use large arrays or underwater farms as we move on. And then, of course, we are working on expanding a project pipeline in some of the most relevant markets around the world, which I will show you in a minute. But let's move on and talk a little bit about the technology until we reach that. So if I can get the next slide, please. I hope that the animation reach through to you, because it will shows you the principle that we're using. We design and build underwater airplanes with an onboard drivetrain with a turbine and a generator. So you can say the nacelle and the turbine generator gearbox there is much the same system solution as a conventional windmill, just smaller scale and a little bit more robust, and hopefully significantly more watertight. And this system is then pushed through the water and driven through the water by the airplane that sails with its wing on the current. So it's propelled into around in this H-shaped trajectory by the ocean current that is creating a lifting force on the wing. This makes it possible for us to sweep a large area of the water. And by sweeping such a large area with a small, lightweight system, we get really good economic generation out of it, because we can sweep that large area. And we can also significantly accelerate the speed of the water through the turbine. So if we would just park this airplane on the seabed, we will get perhaps 1 meter per second flow through it. But when we let the natural flow push the wing, the system will move at the speed up to 10 times that speed of the flow. And that makes it really interesting from a turbine physics perspective, because there's a cubic relationship with how much energy you get out and how much velocity you have in the water. So all those things taken together is really at the core of the competitiveness of Minesto's technology. So apart from being interesting from a project build out and sales and commercialization aspects, I think it's fair to say that if you're looking at a high-tech investment that really carries competitive advantage inherently close to the technology, Minesto is such an opportunity. But let's move on. Let's move on into the actual setup. If I get the next slide, please. Just briefly here, this is the site that we operate in the Faroe Islands together with the local utility, the local electric utility there, SEV. So you see the airplane, the underwater airplane, the kite, or the dragon, as we call them nowadays, tethered to the seabed with a foundation. It can, of course, also be drilled and grouted to the seabed, so we don't have to drag a lot of concrete into the ocean, which is sort of the next natural step of evolution of foundations. And then seabed umbilicals, rather conventional technologies nowadays in transporting electricity on the seabed, and then onshore control stations with a connection to the grid. So this is the setup that we bring to the table. And if I can get the next slide, we'll we'll move into some nice footage from the actual operations from last year in Vestmanna in the Faroe Islands. Fascinating sceneries, those islands here with a population of 50,000 people and an isolated grid. So they need to be really careful with security of supply and keeping the island's energy system operational under all conditions. And this is a story that will show you some of the value of bringing Minesto's tidal energy technologies to a net zero grid mix, or a quest towards a net zero grid mix. And this is what we're doing here in the Faroes. So this utility, they normally don't, invest and work with early stage technologies. But given the potential of tidal in the Faroes and its complementarity to wind and the hydro resource they have, makes this really interesting. And what we've been running is we've been running two kites called DG100s. Those kites are now being upgraded or swapped out into what we now call D4 kites or Dragon 4 kites, which is a significant step performance-wise for us. And we will use the same infrastructure for those new kites as they are transferred into this grid context this year. And some of the advantages of the technology can be seen in the footage here. I mean, one obvious thing is that we can tow the system out. We don't need to lift it. We don't need large vessels to do it. And that open up for rather clever, low-cost O&M concepts for working with it. You also see some underwater footage and some GoPro camera views to show you that the turbine is actually moving here and that the system, as you see it here, is in electricity production. But I think we'll move on and take the next slide here and introduce you to the Dragon class systems. So in the process of maturing the technology, we have during last year, and what we are now building and what will soon be installed is a significant upgrade of the technology. And here you see, for example, I mean, I could probably talk you tired on the details of the changes, but just one illustration. Instead of having a nacelle with a turbine under the wing, the nacelle is now an integrated part of the wing. So instead of creating drag and let's say stealing energy out of it, the nacelle is now a part of the wing and actually captures and collects energy. And that's the kind of changes that has now pushed Minesto's technology into what is not just commercial, commercial demonstration unit. It's really a product range that we are now building the first units. And we are building two large units, the D12s that you see here, which is megawatt plus units. And we're building three smaller 100 kilowatt units, D4s. And one of the units we're building with a little bit larger wingspan, but with the same rated power. Because the flexibility of wingspan is something we will use to be able to target different flow profiles. I think it's equivalent to the wind industry, where you have longer and shorter blades depending on your peak winds in certain sites. So you can optimize in that way. And that's quite a good flexibility dimension for us. We also reduce the number of components, and as you see, we are now pulling the turbine instead of pushing it through the water, which also has a significant impact on flight behavior and energy production. So, okay, next slide, please. To perhaps the most important slide in this presentation, the economic rationale behind this technology. And I think I'm going to spend a little bit more time on this than I perhaps normally do, because sometimes I'm a little bit surprised by the reactions we get when we present this. This is a levelized cost of energy projection for Minesto's deep green technologies at somewhere below a megawatt scale of units. And in the beginning of the build out, we talk about small arrays, 10 megawatt arrays. And when we reached 100 megawatts installed on the x-axis, we talk about 40 megawatt arrays. So economies of scale are still really, really not at our advantage here compared to where we will be in a longer term perspective to compare this, for instance, with offshore wind. But it's important to see that the scale economy is not what drives the cost down here. It's a conventional learning curve where we know from research into basically any new technology from any industry that is being launched, that the learning effects of iterations bring costs down. It's almost a law of nature that this will happen. And Minesto, we are applying really conservative learning rates to this curve. And what is really important to understand is that the performance evidence that we have generated during this autumn in Vestmanna has now put us on the curve towards the left here with the units that we are building now, the D12s, the larger megawatt scale units. And this means if you look in the rear mirror and look at other renewables, both solar and wind and offshore wind, this is quite a dramatic position to be in from the perspective of competitiveness, because entering an industry and entering the market at this level is almost unique. Wind, for instance, has been at least 3, 4, 5 times above this level entering the industry 15, 20 years ago. So this means that when we claim based on material analysis, energy conversion factors, and the operating conditions we have, that we claim that this technology is cheaper than offshore wind. It's not just something that we have as an ambition. It's an analytically based statement based on the low weight, the O&M concepts, and the actual energy conversion. So from our perspective, we are really now looking forward to the catch-up race we have cost-wise with the wind sector moving now forward for this year and onwards. But of course, it's not just a matter of sheer cost of electricity. And I will try to give you a little bit more insights into the concept of base load and complementary predictable renewable energy in a context where we actually are serious about reaching net zero. So to do that, I need the next slide, please. And the next one. Yeah, I think it is, at least for us living in the southern parts of Sweden, it's brutally evident now that that established renewable energy systems based on wind will not give you stable energy markets, and you will not always generate electricity when you need it. So we need to find ways of balancing grids, and it's not just a matter of massive build out of wind that will help to take us to a certain level of penetration. But you can imagine how much wind we will need if we just have, a small breeze blowing. We will need a capacity that is perhaps 10, 20 times the capacity rated power-wise. So this is where we start talking about competitiveness beyond the actual cost of energy. We need to find other ways of generating electricity to reach net zero, to afford this transition. And I think that we all can agree now that okay, there are solutions such as large-scale storage in the future that may be a bet. We can also go all in on nuclear, not short-term. That's a significantly more long-term perspective than bringing ocean energy to a commercial rollout, I would claim. But yes, in this, let's now see when we move on what the real impact of balancing grids with tidal means. So give me the next slide, please. First, yes, the growth on the left. It's a massive growth based on electrification and industrial growth in the world. And we still, on the right, can conclude that it's going to take a while until we have really interesting, cost-effective huge, large-scale seasonal storage solutions. Storage will be helpful. We will use it in different ways, and it will also be helpful for tidal installations. So we are big fans of storage, but we have to acknowledge that the more storage we need to get into an electric network that is net zero, the more costly the electricity will be. It's a safer bet to bet on generating capacity. And if you give me the next slide, you will see an overview, a comparison from the island of the Faroes here, comparing their storage needs with and without utilizing their tidal energy natural resource. And the gap here, and it's actually so that we can discuss whether the gap is potentially even larger than this. But this is a first go data from the local utility, where you can see that for them, hydropower and pumped storage, where you pump water back into the dam to run it through the hydro turbines again when it's no rainy days, so to speak, and when the wind is not blowing. That's the concept here. And it's massive investments in concrete. It's build out of those dams needed at a scale that is almost doubling the capacity, with an enormous carbon footprint and with enormous costs associated with it. So that's the wind scenario. If we can get the predictable tidal energy that runs every day with 4 cycles a day, we reduce this need significantly. It's also a context where we can put farms in different locations where we will have a shift. The tide does not turn at the same time, even in a small place such as the Faroes. So we get a really, really good tool to balance the grid and lower the total capex and introduce a higher security of supply. And I think this is really why Minesto is having such a good position in the Faroes and so much support locally there. And we will see over the year here new plans and the serious build-out phase being introduced with sites for the D12s to start with. So, okay, next one, please. Briefly, if I get the next one on the business model here. Minesto, we are a tech company. We develop systems and should sell systems to the left here as our core business, of course, with a significant aftermarket associated with it. But in this early stage of the sector, site development and collaborations with large developers of this resource and sites is needed. So this is where we're putting most of our efforts now to identify sites, to secure sites, both on our own and also together with others. And this portfolio will grow, and it's necessary that it grows so we can really cherry pick the best locations and partners for the first build outs. Of course, to the right, there are some interesting opportunity also to blend those collaborative projects with different kinds of licensing and local ownership of the commercial agenda. Next, please. So just briefly to say that and what we're talking about here at this stage is to combine both build, the early phases of site development of utility scale arrays, underwater farms, but also to identify the really high cost locations in the world where diesel electricity, high cost markets where diesel is used primarily for electricity, and that's almost all islands remotely located that are surrounded by tidal and ocean currents. Next, please. So to summarize the priorities and what we are right in the middle of now as a company is of course to capture those early stage opportunities to build the first arrays. So we're heavily involved in consenting, in marine licenses, in getting the local port access settings right, and the logistics around those sites, including PPA discussions and local partnerships. What we're doing in Wales and the Faroe Islands is sort of the two first sites that are in lead positions here where we are now. It's also a matter of expanding strategic collaborations. We have signed partnerships with EDF, and primarily with Schneider Electric, and now on the manufacturing side, we're involved in several discussions to strengthen us and give us a more long-term agenda to scale up manufacturing. And also on the project finance and project development side, there is a huge need for this, and that is also a focus for us. And then, of course, for the projects, it is a matter now of using the good investment climate for renewables and the more and more ambitious energy transition agendas in many locations around the world to blend private and public funding into those energy projects, to scale them up quickly and to make them more robust in terms of supporting the build out and the early phase of operations. So I think that pretty much summarizes the agenda we have forward, and perhaps there is one or two more slides left. Let's run through them to get the next with the projects that I mentioned in the Faroe Islands and Wales. And as you see, it's multi-megawatt scale of those. Infrastructure and hands-on site development is ongoing. Next, please. The partnerships on the commercial side of quite the significance. One of the world's smallest utilities to the left and one of the biggest to the right, and one of the leaders in this renewable energy transition as a partner for project and system integration with Schneider puts us where we want to be at the moment. Next, please. And activities, probing activities in a lot of areas, and hands-on activities in UK, France, Taiwan, the Faroes at the moment. And we will add to this list over the year with new opportunities also. Not necessarily that we'll throw ourselves in parallel everywhere, but we need to be there and understand local market conditions and also venture into potential partnerships. There's a huge interest in what we do in areas where they know that they have a tidal resource. So we just have to be clever with how we choose and pick in that context. Next, please. I think we've already covered the onwards agenda here with what we deliver, what we scale up and expand. So for the sake of time, I think it would be really good to invite some questions. Thank you very much for your attention and for listening.
Thank you very much, Martin. Very exciting presentation. So we'll start out with some questions. We'll start with tidal currents existing all over the globe. This is a potentially huge market. What do you see are the biggest challenges or maybe bottlenecks to harvest this energy in a large scale and commercially?
I think that when we listen to the big project developers, Iberdrola, EDF, the big ones, I think it's an interesting challenge to face because they want really big projects, but they also want low-risk projects. So we're offering something that is obviously higher risk because it's an immature technology, and it wouldn't be clever to go into hundreds of megawatts immediately. So it's a matter of balancing that to find those locations where the 10 megawatts or the 20 megawatts can make a difference also from the large players' perspective, and to get them on board in understanding that this is just sort of a first careful necessary step until we can move into the bigger build-outs. I think that is a challenge. And also for immature technologies, the challenge is obviously that we get a lot of questions on do we harm is this in harmony with nature? Do we mess around with the fish or with the sea mammals? We have a lot of evidence, but it's still evidence from single installations and from analysis of data we have. So that's yet another area where we feel that we could move much quicker than potentially the authorities think. So I guess quite conventional challenges in that respect. Maybe a third one is that we've had first generation of systems with both wave and tidal energy historically that have been really, really heavy systems, and it's been a slow commercial progress. So I think that everyone in the large tech-based energy sector, they know that the potential is huge, but there's been a cautious approach to the tidal and marine energy sector at large. So bringing second, third generation systems in with lightweight and with the performance data we show now is a true game changer in that sense, but also a challenge.
Okay. And could you...
Sorry for the long answer.
No, it's very nice. Could you explain a bit more in detail how your projects are financed and talk about that?
Yeah, I mean, the first stage of project development now is funded from our balance sheet combined with the local actors, both in-kind contributions and cash contributions. So if you take the Faroe Islands, the first phase now of build out there with grid connections and site development, those areas have been funded by the utility. We have funded the hardware via EU-based projects. And it's basically the same setup in Wales. But to take the next step to build, the projects that will take you into the first 10 megawatts, we talk potentially about projects with an investment need of around 20 to 35 million euros. And that project funding is something that we are now right in the middle of securing for those sites. And it looks like the governmental push in the energy conversion, quest makes it now attractive also to use some soft funding and public funding as a platform funding for those cases.
How important are the policy initiatives and government subsidies and similar? How much are you in the hands of governments, if you understand?
I'd say that it's not for the microgrid installations, for the smaller scale installations where we can move commercially. It's going to have less importance. We will find those sites and we start, to get the commercial wheels turning. But for really, really large infrastructure build-outs, the energy sector is a government-driven sector. So I think sometimes it's a misunderstanding to think that that we are, it's subsidy-based. Well, the government is the customer in most markets, and you need to have the government as a stakeholder, customer, and player in this. I mean, just simply to use the seabed, you need legislation and you need permits to do that. And if they are not on board, it's not going to happen. So I think it's much more now a matter of it's not like innovation subsidies, just job creation stuff. It's about seriously building net zero energy systems, and in that role, the government is a customer and a partner. So they are vital in that sense, but it's not subsidy or a matter of let's say not being in a commercial context.
Yeah, understood. Now that you have your Dragon class ready, will you spend less on R&D going forward, or do you have any other big innovation projects?
I think big is the big thing here, because the first Dragon, commercial Dragon at utility scale is a 12-meter wing, but we see that we can go after, let's say, 3 megawatt systems with potentially 20-25 meter wingspans to really address the ocean currents, the large ocean currents. So I think it would be really tempting to keep investing to expand the market further into those areas. Then obviously there are a lot of engineering, hands-on engineering needs to keep cutting costs and to improve robustness and so forth. So I would say that the R&D spendings we have, they will remain when you look at a headcount perspective. But don't forget that we have been building the machines as prototypes and developed the sites as prototypes, which then becomes a part of the R&D budget. That will not be necessary because we will have those learning iterations and the new solutions built into products that we sell and products that generate electricity. So in that sense, it's going to be a dramatic lowering of R&D spendings because the learning takes place in a commercial context.
Mm-hmm. Yeah. And with your operations in the UK, what are the potential effects from Brexit for your sake?
Well, it's perhaps going to give the procurement and financial side some headache in how you structure your companies and how you deal with different tax setups and so forth. But in the end of the day, if you are on top of that, you will be able to maneuver in that space. And for us, we have to remind ourselves and understand that the core competence on operations and site installation is in the UK. They are the only team in the world that can operate and run Minesto kites. So they are a huge factor in accelerating the build out. The second factor in this is of course that the European market is the UK to a very large extent. So not being in the UK would be stupid. And the advantage with Brexit is that there is now also competing systems and competing agendas where the UK wants to keep its position as the leader in marine energy. And EU is pushing really hard for blue innovation in this area. So what we are doing and what we see is that there's an opportunity to join forces with both economies and both geographies, and that is what we're doing.
Mm-hmm. And have your projects been affected or slowed down? Anything with travel restrictions and lockdowns?
I mean, it's for us as for everyone else. It's really added struggle and added challenges to run in operations in remote locations. If you need to fix something, it's been difficult to fly over an expert technician on that sensor or whatever it is. We've had our Welsh team fighting hard with quarantines and lockdowns and everything to go back and forth to the Faroes. So it's been a really tough year, and I must say that what the Minesto team has been able to accomplish under those conditions is really more than you can ask for. So I think that's a huge sign of dedication and determination to get the job done. But it's going to be a remaining factor. And I also think from a commercial perspective, what is most disappointing for me is that all the big players around the world that want to come and see our systems are hesitant and are in some ways not even welcome to the Faroe Islands to take a look at this. So let's hope that this now is being pushed down so we can open the doors for our potential partners and existing ones to really bring them over and see hands-on how dragons should be flown to generate electricity.
You recently employed a new head of marketing.
Yes, and head of communications, actually.
Yeah. Could you talk a bit about her and her role?
Her name is Elke Rosiers. She has a very solid background in large infrastructure project investments, also involving government sales and government role in those funding contexts. She's an engineer by training, but with a very broad understanding also in the legal and then the market aspects of things, and has worked with Minesto as a consultant for many years. So she does not need any long lead time to get into her role. And for me, it's fantastic to have Elke on board, since we've been a little bit careful with accelerating the market side of the company. I'd say that we're doing quite the opposite starting last year.
Okay. Time is running up. If we can have one final question, just if you can answer in 1 minute. The big events for Minesto going into 2022.
It is the launch of the Dragon concepts in the water, hands-on. First the smaller ones, and then later on the bigger ones. And then, of course, on the commercial side, to sign up more partners on project finance, project development, market development.
Okay. Thank you very much, Martin, for a great presentation. And this was the last presentation of the day. So I would like to say thank you to all the companies who has been presenting, and to all our viewers and listeners. See you next time.